Complete the square for the following expressions. So we've got x squared plus 4x plus 5. So following what we did in the intro, I need a square bracket with an x in here. And then the plus 5 I copy to the end. Then we take half of the coefficient of x. So half of positive 4 is positive 2. We then square that 2, giving us 4, and subtract it from the end. Then we tidy, and we have x plus 2 all squared plus 1. So let's think about how that works. If I have x plus 2 all squared, we know that that gives me x squared plus 4x plus 4. So if I have x squared plus 4x plus 5, that's got to be equal to x plus 2 all squared, which gives me this. Add an extra 1 because the constant here is 4 and the constant here is 5. Now for the next one, put the square bracket down, we've got a minus 5 at the end. X in here, half of the 6. So half of 6 is 3. And then 3 squared is 9. So we'll take that away. And so we get x plus 3 all squared, take away 14. This is known as the completed square form for this quadratic. Completed square form or turning point form, and we'll look at that shortly. So for the next one, it's the same process. So I have an x, half of negative 8 is negative 4. 4 squared is 16, so take away 16. And so we've got x minus 4 squared, take away 1. And finally, for this one here, half of the 2 is 1, so in here we get x plus 1. 1 squared is 1, so we'll take away 1. We'll have x plus 1 all squared, take away 6. Now, as to what information this tells us, note that here on Desmos, I've plotted y is x squared plus 4x plus 5. So that's the graph that we have here. You can see the vertex or turning point of this graph is at negative 2, 1. My completed square form, which you can see over here, is x plus 2 all squared plus 1. From this completed square form, which is also known as turning point form, we can get the coordinates of the minimum point on this graph. What we do is we change the sign on the positive 2 inside the bracket, but we keep the sign of this the same. And so that's one of the things that completed square form helps with.